To begin using the Geogebra program, we're first going to open our web browser, Internet Explorer. Once Internet Explorer is open, in the web address, please type the following: geogebra.org/web-start/geogebra.html. I'll give you a few seconds to finish that. When you are done, press Enter and proceed to the website. Now that you have the Geogebra program open, I would like you to take a few minutes to familiarize yourselves with all of the different drop-down menus. Under File, Edit, View, Options, Tools, and Help, those are the basic drop-down menus, but if you pay careful attention to the way the program's set up, you will also notice drop-down menus for each of these icons. Take a few moments now and go through each of those drop-down menus and familiarize yourselves with the different aspects of this program. Take special note of any that refer to reflections, translations, or other isometries that will help you as you progress through this lesson. Now I'm going to show you how to create a reflection of a polygon over a given line segment. The first thing that you have to do is make sure that your coordinate plane is turned off. Some of you will have this option on, and to turn it off you'll go to the View option and just click on the Axes tab here, and it will get rid of your coordinate plane in the background. Next, you're going to draw a polygon, so you're going to go to the option for drawing polygons. You can select any different variety that you'd like. I'm going to choose just polygon, and I'm going to draw a polygon starting with point A, B, C, and then back to A to complete my triangle. And then because I want to reflect this polygon over a line segment, I have to provide a line segment. So I'm going to go over to this option where it says line through 2 points. And now I'm going to place a line segment somewhere on this space that I'd like my polygon to be reflected over. You can do it in any way that you want. I prefer a line that looks something similar to this. Now, if I was doing this construction by hand, it would take quite a bit of time. I'd have to draw perpendicular lines from each of the 3 points in the polygon that is drawn through the line segment to its right, and then measure the distances out. The Geogebra program does all of this for us. If I want to reflect triangle ABC, I simply go up to the option for Reflect Object About a Line. I select the object I'd like to reflect, and then the line I'd like to reflect over, and Geogebra does the reflection for me. Now, if I wanted to verify that the measurements that Geogebra did were correct, there are other options that I can do that with. If I go up to, I believe it's this option, distance and length under this option, I can take and measure the distance from point C to this line segment. And you'll see the distance from there. If I want to continue doing that, I can measure from point C to there, and now I have the measurement for C, point C to the line D, and point C prime to D. What I should notice is that those two measurements are the same. You can do this for any given point on those polygons and determine that the measurements are the same. Next, I'm going to show you how to take a polygon and rotate it around a given point. The first thing I'm going to do is come back up here from this drop-down menu and select Polygon. And again, I'm going to draw a triangle. And then I'm going to come over and select points and plot a point somewhere on this blank space. So point D is going to be my point of rotation, and triangle ABC is going to be the polygon that I rotate around point D. We know that negative rotations have a clockwise rotation, and positive degree rotations have a counterclockwise rotation. So what we're going to do is come up here, we're going to select from the drop-down menu, rotate object around point by angle. Now it asks you to select the object you'd like to rotate, and then the center of rotation, or the point you'd like to rotate around. Now it asks you for the degree of rotation. I would like to make a 125 degree rotation, and I would like it to be a positive rotation, so it's going to go clockwise, counterclockwise around that point. All I have to do is click OK, and my triangle has been rotated. Now, to ensure that the triangle has been rotated correctly, we still want to make sure that the distances between each of the points and the center of rotation are the same. So one of the things that we can do is we can come up here and measure the distance between a given point. I'm going to choose B to D. That distance is 1.8. B prime to D, and find that that distance is 1.8. So I can confirm already that my distances are correct. Secondly, I want to confirm that the angle that I rotated is correct. So I'm going to come back up here and I'm going to measure the angle, starting with point B through D to B prime. Notice that that angle measures 125 degrees, and it is in the counterclockwise direction.